So far, we've learned what complex numbers are and how to perform operations on them. Now let's answer an interesting question. Can we represent a complex number visually, just like we represent real numbers on a number line? The answer is yes, and that's where the Argand plane comes into the picture. In the Cartesian plane, every point is represented by an ordered pair x, y. Similarly, every complex number a plus ib can also be represented as a point. Here, the real part is plotted along the horizontal axis, while the imaginary part is plotted along the vertical axis. For example, the complex number 2 plus 4i is represented by the point 2, 4. Likewise, minus 2 plus 3i becomes minus 2, 3, and 1 minus 2i becomes 1, minus 2. This special coordinate system is called the Argand plane. It allows us to visualize complex numbers geometrically, making many concepts much easier to understand. Now let's move to the second major topic of this chapter, quadratic equations. We already know the quadratic equation has the form ax squared plus bx plus c equals 0, where a is not equal to 0. When the discriminant b squared minus 4ac is positive or 0, we can easily find real roots. But what happens when the discriminant becomes negative? Earlier, we would simply say that no real roots exist. But now, because we have introduced complex numbers, we can still solve such equations. Instead of stopping at the square root of a negative number, we express it using I. This allows every quadratic equation to have solutions, even when the discriminant is less than 0. The general solution remains the same, except that the square root of the negative discriminant is written in terms of I. This leads to two complex roots. An important result related to this topic is the fundamental theorem of algebra. It states that every polynomial has at least one root. In fact, a polynomial of degree n has exactly n roots when complex numbers are included. This is one of the most powerful ideas in mathematics because it guarantees that every polynomial equation has a complete set of solutions. Let's take a simple example. Suppose we have x squared plus 2 equals 0. Rearranging gives x squared equals minus 2. Taking the square root, we get x equals plus or minus root 2 multiplied by I. Although these are not real numbers, they are perfectly valid complex solutions. Now consider x squared plus x plus 1 equals 0. The discriminant is 1 minus 4, which equals minus 3. Since the discriminant is negative, the roots are complex and we simply apply the quadratic formula using I. This shows how complex numbers extend our ability to solve equations that previously seemed impossible. By the end of this video, you've learned how every complex number can be represented on the Argand plane and how complex numbers make it possible to solve every quadratic equation, even those with negative discriminants. In the upcoming videos, we'll solve plenty of examples, learn shortcuts, and master exam-oriented questions from this chapter.